This is going to be an experiment in more ways than one. We're going to see how well we can do with a laboratory when I have to essentially just narrate what's going on in the lab. And I'll also mention to you what occurs at certain times. You can record those observations and tell me what you think about them. You're responsible for making the conclusions and the write-up of the laboratory itself. This lab is going to be divided into three parts. The first part is the physical and chemical changes, just to introduce that concept, and I'm sure it's something you're very familiar with. A physical change is one that does not alter the identifying properties of a substance, right? It can change its form, state, energy level, but there's no permanent change that occurs in the properties of the substance, okay? So you can take a piece of paper and cut it in two. That's a physical change. You can evaporate something so it goes from a liquid into a gas. You can take a gas and you can condense it into a liquid. You can melt something, you can freeze something, dissolve something. All those different things are physical changes. A chemical change is one that produces a new substance with new properties. Okay. So anytime something burns, you've got gases, ash, residual materials. That is a chemical change. Heat, light, electricity are often produced as a result of these chemical changes. And that's some of the ways you can tell a chemical change has occurred. Also, if you see the evolution of bubbles, that means a gas is being formed, and therefore a reaction has taken place. So, chemical changes occur when atoms combine to form new compounds, compounds break down into simpler substances, or compounds react with other compounds to form completely new substances. So what we're going to do, or try to do here, is just to check out your understanding of these type of ones. And if we were in the lab, well, we'd have something like sodium chloride, which is you have at home there. It's table salt. An evaporating dish, well, that can just be a little bowl of something. Nichrome wire. The old, that would be the filament in an electric light bulb, for example, or I guess you could get it from a hardware store. Tongs, because you want to hold something. A magnesium ribbon. If you don't have a magnesium ribbon, another way of looking at how magnesium reacts is if you've got a highway flare, that's usually made up of magnesium, where you pull something and the magnesium ignites. Small dilute hydrochloric acid, silver nitrate. It says here copper 2 chloride solution and aluminum foil. In place of that, we are going to use white distilled vinegar for this one, and instead of aluminum foil, we are going to use baking soda. Again, hopefully both materials you've got easily on hand at home. You can do these yourself, or you can. We will talk about them. So if you dissolve sodium chloride, table salt, in water, what happens? Observe what happens with the salt. The water levels doesn't really change, does it? Okay, this is one where you taste the solution. If I were going to do this at home, I'd do it with sugar, maybe with put it in coffee instead. You can't really see it, but the taste means that it has dissolved into the liquid, right? You're no longer just licking a sugar cube. Also, you can continue dissolving until 10 grams, okay? Once you get to 10 grams, what happens is after each one, it's going to have a little saltier taste, right? I mean, everyone understands how the more you add of something, the more of that taste you're going to get. With the sugar example in coffee, eventually you're going to be able to stand your spoon up in the coffee with it. It will become almost like a syrup. And then what you're going to do is then, once it's all finished, you take a little bit of that and you put it in that dish and put it on the oven or someplace to allow it to dry. And what happens is a solid will remain, right? So in each one of these, except for when you were tasting it, all that was happening were strictly physical changes, weren't they? Now, that nichrome wire, Okay, it's got a shiny color to it, like most metal, and well, this is nickel chromium combined together, but it's still a metal, and so it's going to have a shiny luster. It's going to be somewhat, well, it's flexible in terms of being able to bend the little wire, but and then if you heat that, what happens is it's going to glow brightly, but then once you pull it away, it's going to return to the same thing. So all you have done here is you've not caused it to undergo a chemical reaction. It still is a physical change. The next one, though, here you've got 5 millimeter length of magnesium ribbon. Or if you're going to do this outside with a flare, I said if you're going to do it with a flare, do it outside. Nobody wants to have a flare inside the house. And you'll notice that normally magnesium has got a metallic luster to it. It's somewhat flexible. However, when you ignite that, that is going to be a bright, glaring flame. There's probably someplace online where you can look at magnesium fire and see that, where if you don't have a flare handy at home. So when you have something like that, you are actually getting more of a chemical change, aren't you? It is burning. Once it's burned and released all of that energy through heat and light, you just have a little bit of residual powder left behind. Now, if you were going to if you poured silver nitrate into a small test tube and added several drops of dilute hydrochloride, and you swirled it around, okay, with the addition of each one, what happens is a white precipitate forms, right? So this isn't a change because of a change in temperature. It's a change because a new material has been formed. You've gone from silver nitrate to silver chloride. Silver nitrate is soluble in water. Silver chloride is not soluble in water. You don't have to do the filtering and leave it. If you leave it in the sunlight, it's going to change color again. So that will be another change there. Next, what you do is you take distilled vinegar. If you don't have to have a beaker. You can just have a little cup there. And it's best if you have a clear glass, right? A little small juice glass. And then and the beaker feels cool or warm to the touch. Well, it just depends upon how warm things are in your kitchen. Once you add baking soda, that's sodium bicarbonate, to that, observe what happens. I'll tell you what happens. What happens is you get a whole lot of little bubbles coming out of that very, very vigorously. Okay? And then we touch it now. That actually is very hot. It's going to be exothermic reaction. In other words, heat's going to be given off for that one. So, and that's the one, instead of aluminum foil and copper chloride solution, record that here. Scratch this out and put in there baking soda in the distilled white vinegar. Okay? And the reason why I use distilled white is because if you use the typical apple vinegar, it's got a yellow color to start with, and it doesn't show the results quite as well. So now we know what sort of things you should have observed here, and so you write down what those observations were that we talked about. And now what you're going to do is you're going to fill in and answer these following questions right here. The changes that occurred, and comparing the different ones for all these different conditions. Okay? And then it's right here. We did change it to sodium bicarbonate and vinegar. I'll try to make certain I make all the other changes. And there was more than one change here. Okay? So just make certain you note all of them on that one. The next part of the lab is called lab safety. And this is one you can read through. And normally if we were in the lab, I would go through every single one of these points in detail because it's extremely important before you do anything in a chemistry laboratory. But I will let you read through these, and once you get to the part where you're answering questions, you should, from that information, be able to do that, except you're not going to be able to draw a diagram unless you've got a photographic memory of where everything was in our lab there. But anytime you go into a lab for the first time, if you're going to do chemistry experiments, these are the sorts of things right here. Where's the foam? Where's the fire extinguisher? Where's the alarms? Where's the fire blanket? Where's the eye wash? Where's your first aid kit? Where's your deluge safety shower and something that gets splashed all over your body? You should know all of these for your own safety, okay? So also, the emergency plan for evacuating the building. Irrespective of what sort of activity you're doing, you should always know this, and even if it's an apartment building where you're living, or a hotel where you're staying just for one night. What do you do in these different events? All of those are based upon the information that's presented up above. Okay? Now, the next and final part is the introduction to lab equipment. In most labs, it's the same basic equipment, and we've got it all right here. This right here is your beaker. You've got your Erlenmeyer flask. You've got your wash bottles. You've got your graduated cylinders, your burettes, your ring stand. We don't have this type of Bunsen burner. We've got a different type, and the clamps, and this is their evaporating dish. So all these different ones you should be familiar with, okay? You should be familiar with what each one of those looks like and also what they would be used for, okay? If you've got any questions on what any of them are used for, the difference between an Erlenmeyer and a Florence flask and a volumetric flask are the following. An Erlenmeyer flask is used for when you are going to put something into or expect to precipitate to form, okay? And so you can then pour off or decant the liquid from the top of this. A Florence flask is used for when you are doing a reaction. This is the type that you usually see in the laboratories where the mad scientist has the multiple different ones of these connected with tubing, and each one's boiling in a different color, right? Volumetric flasks are when you're making up solutions. You add a certain amount of the solvent that you're going to be using, such as water, and then you add your solute, the material you're going to dissolve in there, and then you raise it up to and there's always a specific mark on here that tells you how far you have to raise it to have exactly that liter or that fraction of a liter present in there, okay? So that's the distinction between those three things right there. Burettes are used for titration. Pipettes are used for removing small amounts, drops or things like that, from one solution to another. Crucible tongs are used for carrying these, and then also test tubes are used. Test tube clamps are used for moving test tubes around. So all of these different things have a specific purpose. You put this on here, cover it with a material, something that you can then put your heat underneath here. Usually there's a type of wire gauze that you add to the top of this. If you've got funnels, you put them along in these things. But what I'd like you to do then is then use this and provide an appropriate use for each one of these in a laboratory. Okay? Beakers, for example. You use different size of ones to measure things out when you're putting it on from a scale and determining how much you're going to be using of that. The mortar and pestle. That is used when you grind materials up to get a very fine powder so that it goes into solution easier. Watch glass is so that you can observe something that's being evaporated. Graduated cylinder is, again, you are using very specific volumes of a material. Hot plate and burners are just to heat things. But anyway, you should have an idea of all the different things on here, and then complete that and then send it back to me for a completed lab grade. Thank you.